Okay, so in this video, we're going to talk about the various application of inverse function, domains, and ranges. So the first application, let's talk about that of inverse function. Now, a question can give you a function. You have f of x as x minus 2 over x minus 3. And you ask to look for the inverse of this function. This is a function that has an equation. So you ask to look for the inverse. Now we have to go in a series of steps. So step one is to equate or exchange or replace f of x with y. So just plug this as y is equal to x minus 2 over x minus 3. Now your step two is to make x the subject of the formula. So you have to cross multiply. You have y into bracket x minus 3 is equal to x minus 2. So open this bracket. You have xy minus 3y is equal to x minus 2. You bring x to, since you want to factorize, since you want to make x the subject, you bring all the terms or the variables that has x to one side. So you have xy. This crosses over, it becomes negative x is equal to, when this crosses over, it becomes positive 3y minus 2. So you bracket, you factorize out x. So you have x y minus 1 is equal to 3y minus 2. So you divide both sides by y minus 1. So you have your x to be 3y minus 2 over y minus 1. Now step 3, all you have to do in step 3 is to replace x with y and replace y with x. So anywhere you see x, you replace it with y. Anywhere you see y, replace it with x. So this x becomes y is equal to, this 3y becomes 3x minus 2 over x minus 1. Now your step 4 is kind of similar to your step 1. Now your step 4, you have to replace, just like the way you replaced f of x with y, now you have to replace y with the inverse function. So f inverse of x is now going to be 3x minus 2 over x minus 1. So this is the inverse of this function. Step 1, you replace f of x with y. Step 2, you make x the subject. Step 3, you replace x with y and y with x. Step 4, you replace y with f prime of x. It's just 4 steps. Now, we are going to revisit some examples, come back to some examples on this. But let's talk about the applications of domains in calculation. So before we talk about the applications, now there are several ways of representing your answers of a domain. For instance, let's say we have a function f of x being 2x minus 7, and we want to know the domain of this. All we simply need to know is the set of values of x that can fit into this equation to give us an answer. Understand? So the answer for this kind of equation can be represented in two forms according to this video. You can represent it in the set builder form, and you can represent it in the interval notation. So we talked about set builder form when we discussed sets. So now let's talk about interval notation before we come back to this question. So interval notation. Let's say we have a sequence of values. Let's say we have 2, 3, 4, 5, 6, 7, 8. Now this is a sequence of values, right? Now in interval notation, we have two things we consider. We have what is called a bracket. is like this. And we have what is called a parenthesis. Parenthesis. It's like this. So the bracket is kind of like edgy. Parenthesis is kind of like curved. So this set of numbers, what is the range? The numbers are from what? 2 to what? 8. So in order for you to represent this in interval notation, now the difference between a bracket and a parenthesis is that when you use a bracket, it shows that the number that is directly close to the bracket is involved in the list of numbers. What do I mean? So in order to represent this set of numbers in interval notation, use a bracket. You can say 2, 8. So this is the range of numbers, very simple. Now, how do you use a parenthesis? Now, we know that these are our sequence of number, don't forget. But before 2, there's 1, Abi. So there's 1 here. But it's not among our sequence of numbers. I'm just trying to illustrate something. After 8, there is 9, right? So in order to represent this in another format, instead of using this form, we're going to use the parenthesis. So the parenthesis now, in order to represent the parenthesis, we'll use the number before. So you have 1, 9. What does this mean? It means that the range of numbers, 1 is not among, but the number after 1 is the beginning of the range of that number, you understand? So it's different between a parenthesis and a bracket. Sometimes you can combine them. So if you want to combine them, you can use, for this particular example, you can say parenthesis 1, meaning the set of numbers starts after 1, comma, 8. This can work, you understand? So it means 2, 3, 4, down to 8. Or you can have set of numbers starting actually from 2 and ends with 9. Use a parenthesis, meaning the number that ends that sequence is before 9. Understand? So this is just a little representation of what interval notation is talking about. Now let's try to generate some exceptions or some examples of interval notation. So we have, let's say we have a table and we want to discuss, okay. Now let's say we have x is greater than 2 or x is greater than 4. So what is the representation of the interval notation? Now we have our number line this way, right? And at our number line we have 0, we have 1, we have 2, we have -1, we have -2. Now this number line is going to continue, you understand? Because the numbers are unending. So we just use a symbol called infinity to represent the end of a number line. So infinity, this is positive infinity and this is negative infinity. So if they say x is greater than 4, let's say this is 3 and this is 4. If they say x is greater than 4, what does it mean? It means that x can be 5, 6, 7. X is greater than 4 means x can be 5, x can be 6, x can be 7, x can be 8, and so on, down towards infinity. Now, in order to represent this in interval notation, you can represent the start of the x cannot be 4, so x can be 5, so we have a bracket, 5, comma. Now, a number cannot be infinity, you understand? Infinity is just a symbol that represents the unending sequence of numbers, you understand? So if you write infinity, you have to use a parenthesis. You cannot use a bracket for infinity, you understand? So what does this mean? If you say this, it means that x can start from 5, 6 down to infinity. Another way of representing this is actually using 4. So this can be 4, comma, infinity. You understand? So let's make use of this. So we have 4, infinity. Very simple. So we go over to another inequality. So this inequality, let's say x is less than 4. So you can have your number line once more. You can have 4, 3, 2, 1, 0, -1, down to negative infinity. We have 5, infinity. You understand? So x is less than 4, meaning x cannot be 4, but x can be 3, x can be 2, x can be 1, x can be 0, -1, -2, down to what? Negative infinity. So if you want to represent this, you can either say, you can use a parenthesis, negative infinity, comma, then what x can actually be, which is 3, use a bracket. Or you can say negative infinity, comma, 4, use a parenthesis, because it cannot be 4, it must be less than 4. You understand? So this is going to be negative infinity, comma, 4. So this is just another way. Now we can have, let's check another inequality. We can have x to be greater than or equal to, let's use 3. X can be greater than or equal to 3. What does this mean? It means that x can be greater than. X can be greater than means x can be 4. Okay, let's have a number line. We have 3, 4, 5, 6, down to what? Infinity. Now we have 2 here. What does this mean? It means that x can be greater than 3 and x can actually be 3. You understand? So x is greater than or equal to 3. So the series of numbers here on the sequence starts from 3 and ends with 3 to what? Infinity. So 3 is among, right? So use a bracket. So we have 3, comma, infinity. Don't use a bracket. Understand? Or you can say 2 with a parenthesis because it's not among. So the number after 2 starts the sequence. And use this. So let's make use of this since there's 3 in our question. So we can have 3, comma, infinity. So we go over to another one. Go over to another inequality. Let's say x is less than or equal to 3. So you can have this, you can have 3, 2, 1, 0, -1, down to what? Negative infinity. So the range of values here, x can be less than 3 or equal to 3. So the range of values is 3, 2, 1, 0, down to what? Negative infinity. So using your idea of brackets and parentheses, negative infinity cannot go with a bracket. So you're going to use a parenthesis, comma, then the last range is 3. Use a bracket. Or you can have negative infinity, comma. What comes after 4 is, what comes after 3 is 4. So you can have this. So you have negative infinity, comma, 3. So let's take another inequality. Now let's combine more than one inequality. So you have let's say 3, okay, let's say 2. 2 is less than x, which is less than, let's say, 4. Yeah, okay, let's say x is, yeah. All right. So let's use a larger number. Let's say 6. Now, what do you want to do first of all? You want to break this down. So you have 2 is less than x, which is less than 6. Now, this is just a combination of two inequalities. So you know that 2 is less than x. So 2 is less than x. And you know that what x is less than 6. Another way of writing this, if 2 is less than x, means that x is greater than 2. So x is greater than 2 and x is less than 6. So these are two inequalities. Do you understand? Now, how do you represent this in a number line? Or what are the range of values? So if if x is greater than 2, it means the numbers can start from 3, 4, 5, but you cannot add 6 because x is less than 6. So this is the range of values. Let me use a number line to represent it. You can have 1, 2, 3, 4, 5, 6. Now they said x is greater than 2. So it means that any number that starts after 2, you understand, this way. And they also said x is less than 6. So any number that goes before 6. So this is the range of values, 3, 4, 5. So how do we represent this in form of an interval notation? You can either use a bracket, you can say 3, 5, or you can say what comes before 3, 2. What comes after 5, 6. So let's use 2 and 6 because 2 and 6 is part of our question. So you have 2, 6. So let's take another one. You can have 2 is less than or equal to x, which is also less than 6. So this time around, we're working with same number line. We have 0, 1, 2, 3, 4, 5, 6, 7, down to infinity. And they say 2, okay, you have to break this down. You have to break it down first. 2 is less than or equal to x, and x is less than 6. It means that 2 is greater than or equal to, okay, x is greater than or equal to 2, and x is less than 6. So x is greater than or equal to 2. What does it mean? It means that x can actually be 2, and x can be any of these numbers, you understand? But where is the limit? It means that x is less than 6. So it has to be from 2, but before 6. So x can be 2, it can be 3, it can be 4, it can be 5, but it can't be 6, you understand? So how do you represent this in form of interval notation? You can use a bracket, 2 and 5, or you can have 2 and 6, or you can have 1 and 6. So it depends. So now let's make use of this since we have 2 and 6 in the question. So this is 2, 6. So let's take another inequality. Let's say 2 is less than x, which is less than or equal to 6. So we know that the range of values will be, okay, we have to break this down. So 2 is less than x and x is less than or equal to 6. So it means that x is greater than 2 and x is less than or equal to 6. It means that the range of numbers can start from 3, 4, 5, and include 6 because there is the equality sign here. So in order to represent this, you can use can use a parenthesis. So the number before 3 is 2, comma, and you can use 6 with a bracket. So we go over to the next. You can have 2 is less than or equal to x, which is less than or equal to 6. So this is very simple. It just means the range of numbers starts from 2 and ends in 6. No need to go through all the trouble because we didn't know what we're talking about. Now, for real numbers, yes. Real numbers, you have to include that. So for real numbers, a set of real numbers. What are real numbers? Real number comprises of both natural numbers, integers. So real numbers are everything on the number line. So if you have a number line 0, -1, okay, sorry, 0, 1, 0, 1, -1, infinity, -infinity. Real numbers are everything on the number line, you understand? So you start from, so real numbers, you're going to have -infinity, comma, infinity. Remember, infinity does not go with a bracket because no number can be infinity. So this is basically just few inequalities and interval notations, which this is inequality. This is interval notation. So now we go back to our application. Remember, we are still in the applications of sorry about that. Now the application of domain in calculation. So we have several cases. So case 1, talking about linear functions. Linear functions. So for linear functions, it's just a function that has a linear equation. Now what is a linear equation? A linear equation is just an equation that is not a fraction or an exponent or a logarithm and stuff like that. So if you have a linear function, f of x is equal to 2x minus 7. So if you're asked to find the domain of this, what you're simply asked to do is the domain D is to look for the set of values of x that when you plug it into this equation, you get an answer. So let's say you have 1 as a value, 2 into 1 minus 7. This is 2 minus 7, which is -5. This works because this is an answer. Whether it's negative or positive is an answer. Let's say we have 4 minus 7. 2 times 4 gives 8 minus 7, which gives 1. This is also an answer. So you can see that any value you use, you can even use a negative value. Let's say we have -1, 2 into -1 minus 7, minus 2 minus 7, which gives -9. This is also an answer. So you see that any number you use, any number at all that you use, you're going to get an answer. So what do you call a range of any number? You call them real numbers. So you have to represent this either in terms of set builder. So in set builder form, it's going to look like this. The domain is any set of number x such that x is an element of a real number. Or you say the interval notation D is going to be equal to real numbers, which is -infinity, comma, positive infinity. So let's take another linear function. F of x is going to be x squared plus 3x minus 5. So any number you plug into this equation, you're going to get an answer, regardless of the power, you understand? So the domain is still going to be these two answers. Let's take another one. We have f of x to be 2x squared minus 5x. Okay, 2x cubed, sorry. 2x cubed minus 5x squared plus 7x minus 3 is still going to give you the same answer. So all linear functions gives you the same domain. Now this is for case 1. Now case 2 is fractions. Fractions. If you have a fraction, now let's say you have a fraction, x minus 2 over x plus 3. Now you can plug in any value into this fraction and get an answer. The only exception is you don't want to have 0 as the denominator. You understand? You don't want to have 0 because when you have 0, if you have 4 divided by 0, this is undefined. So you won't have an answer. So that's the only exceptions to fractions, you understand? So try as much as possible for the numerator, for the denominator, which is x plus 3, to not be equal to 0. This is the only exception. So let's take an example of trying to look for the domain of a fraction. So let's say f of x is equal to 5 over x minus 2. Now the only exception is that x minus 2 must not be equal to 0. So any number can go, you understand? All real numbers can go, but the only exception is this. So if it's like this, let's make x the subject. X now will not be equal to, when this crosses over, it is equal to 2. So what does this mean? It means that x can be greater than 2. Okay, x can be less than 2. And x can be greater than 2. That's what this means. Do you understand? X can either be less than 2 or x can be greater than 2. So how do you represent this in interval notation? Now, we did something when we talked about interval notation. We said, okay, I think, yeah, x is less than 4. So x is okay. Pause. You can pause the video and try to translate these two inequalities to interval notation. So x is less than 2 is going to be represented this way. Infinity. Okay, negative infinity, comma 2. Then x is greater than 2 is going to be represented this way. 2, comma, positive infinity. So this time around, we have two inequalities, you understand? So if you have a case where you have this, you can join the both of them using union. Understand? So your answer for this, so this is your domain. Your domain is this. Now, in order to write this in set beta form, it's going to be very easy. So domain is going to be x can be any number. X is a number such that x is an element of a real number, but x is not equal to 2. So I think the set beta is even more easier. So you can either leave your answer this way or this way. Understand? So we'll take another example. Example 2. Okay. Still under fractions. So we have x is equal to 1 minus 4x over 2x minus 1. So now x can be any number. So, but x cannot be, okay. 2x minus 1 can never be equal to 0 for this to work. So this crosses over. We have 2x is not equal to 1. Now you divide both sides by 2. So you have x is not equal to 1 over 2. So in order to write this in a simple form, in your set beta form, the domain is equal to x, such that x can be any number. X is an element of real numbers. Real numbers are any numbers. Then you state the condition. The condition is x cannot be equal to 1 over 2. In order to get this in set builder in interval notation, you have to break this down. So if x cannot be equal to 1 over 2, it means that x can be greater than 1 over 2. Okay. It means that x can be less than 1 over 2 and x can be greater than 1 over 2. What do I mean by this? You have a number line. You have 2, 3, 4. You have 1, 0, -1. And they say x cannot be 2. So x can either be greater than 2, or x can be less than 2. That's what I'm trying to illustrate here. So we talked about how to tackle this kind of inequality. So for x is less than 1 over 2, it's going to be negative, okay. It's going to be negative infinity, comma, 1 over 2, union. I told you to join two interval notations, you use a union. Union 1 over 2, comma, infinity. Notice something that when I wrote out the two interval notations, I found a way to put it such that the infinities are the extreme. I didn't write it this way. Understand? To find a way to put it so that negative infinity will be here and positive infinity will be here. So in order to leave our final answer, is going to be the domain is equal to negative infinity, comma, 1 over 2, union 1 over 2, comma, infinity. So let's take another example on fractions. We have f of x to be 3x minus 8 all over. Now we have a quadratic x squared minus 9x plus 20. So this can work out. Any number can go here, but the denominator cannot be equal to 0. So x squared minus 9x plus 20 cannot be equal to 0. So we have to solve this inequality. So when you factorize this, you're going to have x minus 4 and x minus 5 is not equal to 0, meaning that x minus 4 is not equal to 0 and x minus 5 is not equal to 0. It means that x cannot be equal to 4 and x cannot be equal to 5. So this is a bit tricky because you're going to have 3 interval notations here. Now what do? The best thing to do is you can break this down to x can be less than 4 and x can be greater than 4. X can be less than 5 or x can be greater than 5. So you have to use a number line. I know somebody will want to just use this, put unit in all of them. No, but you have to represent it to actually understand it properly. So you have, you can have negative, let's say negative 2. You can extend this negative infinity. You can have negative 1. You can have 0. You can have 1, 2, 3, 4, 5. 6. So this little number line has all the numbers, you understand, from negative infinity to positive infinity to all the numbers in between. So let's use this format now. So x can, they said x is, let's use this first inequality now. Now x is less than 4, meaning x can be any number here. and x is greater than 4. So the only exception is that x cannot be 4. So remove 4. X cannot be 4. But x can be any other number, you understand? Now, the next one is x is less than 5 and x is greater than 5. So what does this mean? It means that x can be less than 5 or x can be greater than 5. But x cannot be 5. Do you understand? So this 5 is out. Just the way 4 is out also. So let me go over it again. We drew a number line that has all our numbers, you understand? It said x can be less than 4. So x can be anything from here down. And x can be greater than 4. It means x can be anything from here up, right? Now, they also said that x can be less than 5 and x can be greater than 5, you understand? So x cannot be 4 or 5. So how do you represent this in interval notation? It means that x can be negative infinity. Use a parenthesis because negative infinity cannot be among, a comma. Now, you're going to break this down, this first set of numbers, second set of numbers, and third set of numbers. So for the first one, from here to here, you can either use this to, you can say 3. You can use 3. Union. Now, I know you just want to skip 4 and 5, but between 4 and 5, there's 4.1, 4.2, 4, you understand, 4.5. So you need to indicate that there is a range of numbers between these two. What do I mean? This is 4. Let's say this is 4.1, this is 4.2, down to 5. So you have to indicate this to be 4, 5, meaning there's a list of numbers between them. So 4, 5, union, then the third range of values from 5 down to infinity. So you can still have 5 down to infinity. Another way of representing this is using, instead of using this bracket, you can say negative infinity, comma, you write the actual number 4, use a bracket instead of a parenthesis, union 4, 5, union 5, infinity. So this is your domain. This is your domain. So this is your domain. In order to represent this, you have to indicate your D. Now your domain, in order to write this in set builder form, it can be a set of, x can be a set of numbers such that x is the element of a real number, comma, but x cannot be equal to 4. We're talking about from this point, exceptions, and x cannot be equal to 5. So these are the two ways of representing this, you understand? Now we go over to another example under this. Yes, so okay, before that we go to the next section. Okay, the next case is if you have a square root. So case 3 is when you have a square root. So for square roots, now if you have a square root, any number can be inside the square root, but a negative number cannot be inside the square root. Square root of 4 gives you 2, because 2 times 2 gives you 4, right? But we have square root of negative 4. Minus 2 times 2. Minus 2 times minus 2 gives you 4. 4. 2 times 2 gives you 4. So this is an error. If you use the calculator to try to get this, you get an error. Now, it means that for a square root, a negative value cannot be inside the square root, you understand? For you to get a real number, a negative value cannot be inside the square root. So what do you do then? Now, what are the negative numbers? In a number line, after negative 1, we have 0, we have 1, we have 2. So for a negative number, in order to avoid a negative number, you can only have something that is greater than or equal to 0. Means you can have 0, you can have 1, you can have 2. So for the exception in terms of a square root, the only exception is that the contents inside the square root must be greater than or equal to 0. Let's take an example. We have f of x. Remember, we are still looking at the applications of domains, how to look for domains of various functions. We have a square root of 7 minus x, right? So the contents inside the square root must be greater than or equal to 0. So 7 minus x must be greater than or equal to 0. Try to make x the subject. Now x crosses over. Yeah, when you're dealing with inequality, please, it's better to make x positive. It's better to always make x positive. So x crosses over. 7 is greater than or equal to x. Now, if 7 is greater than or equal to x, when you flip it, it means that x is less than or equal to 7. Now, go back to our interval notation. So when you say x is less than or equal to something, it's this. So we have to use it if you don't want to stress much. So x is less than or equal to 7 is going to be negative infinity. X is less than or equal to 7, comma 7 with your brackets, you understand? Now, this is your domain. Understand? This is your domain. So your domain is equal to this. It means that if you use negative 4, you plug it in, 7 minus 4, 7 plus 4, you have 11. If you use negative 6, you have 7 minus 6, you get an answer. Down to 7, 7 minus 7 gives you 0. So that's the range of values. So how do you represent this in set builder form? So your domain is going to be equal to x, such that x is an element of real numbers. Yes, you always have to put this so that it shows that x can be any number, you understand? But x in this case is less than or equal to 7. Your solution from here. So I think this is even a bit easier. So now let's go to a combination of two rules. So let's take another case. F of x is equal to 6x over square root of 4 minus 4x. Now this is a combination of two cases. The first is that it is for a fraction, we said the denominator cannot be equal to 0, right? And for the contents inside the square root, we said it must be greater than or equal to 0. So combination of those two things, it cannot be equal to 0, greater than or equal to 0. So what do you remove? If you remove the equality sign, you're going to have greater than 0. What do I mean? Something cannot be equal to 0, and something can be greater than or equal to 0. This cannot be equal to 0 has taken out the equality of 0 here. Understand? So a combination of these two, what is left is just greater than 0. So the contents inside here can just be greater than 0. It cannot be equal to 0 because it is a fraction. Do you understand? Now, so 4 minus 4x is greater than 0. Remember what I said, try to make the x the positive one. This crosses over. 4 is greater than 4x, divide both sides by 4. So we have 1 is greater than x. What does this mean? That x is less than 1. In interval notation, x being less than 1 will be negative infinity, comma 1. So this is your domain, okay? Let's represent your domain. Now your domain here is going to be negative infinity, comma 1. Or in set builder form is going to be x such that x is an element of R and x is less than 1. That's your domain. Now, the last part we're going to talk about is the last condition. The last condition is going to be, that's case 4. Case 4 will be for natural logarithm, that is log or ln. So when you have log or ln, you understand? So the natural logarithm. So let's take an example. Let's say we have natural logarithm of 3x plus 15. Now for natural logarithm, we set whatever is inside here to be greater than 0. You understand? It must be greater than 0, because if you use your calculator and you do natural logarithm of 0, you get undefined, or ln 0 is undefined. So for this, you set it to be greater than 0 always. Now, so 3x plus 15 is greater than 0. 3x is going to be greater than negative 15. Divide both sides by 3. Negative 15 divided by 3. X is greater than negative 5. So how do you represent this in interval notation? Your domain will be negative 5, comma infinity. Or in your set builder form, x is such that x is an element of real numbers and x is greater than negative 5. Now we'll take another example. This example has a combination of two cases. So you have the natural logarithm of the square root of 1 minus x squared. Now, for this, remember what we said. For natural logarithm, is going to be greater than 0. The equation is greater than 0. For anything under a square root is also greater than 0. So this works too, you understand? It must be greater than, for, I think the condition for square roots must be greater than or equal to 0. So for, we said for square roots, the inside must be greater than or equal to 0. So this can work out, but we cannot have, it can't be equal to 0, because for logarithm it must be greater than 0, you understand? So we're going to have 1 minus x squared be greater than 0. Remember, always try to make, you can make, we can apply the difference of two squares here. So I have 1 square minus x squared greater than 0. Applying difference of two squares here, we have, if you have a square minus b square, it gives a minus b, a plus b. We've talked about this quite a lot of times. Now, we're going to have 1 minus x, 1 plus x greater than 0. So it means that 1 minus x is greater than 0 and 1 plus x is greater than 0. Try to make x the subject. Remember, try to always make x positive. So 1 is greater than x. What does this mean? It means that x is less than 1. You can take away 1 here. So x is greater than negative 1. So then how do you represent this in interval notation? So you have a number line. And you have -1, -2, 0, 1, 2, infinity, negative infinity. Now they said x is less than 1. So x can be any number but 1. And x is greater than -1. So x must be greater than -1. It means that the range of values lie between here. X is greater than -1 and x is less than 1. So how do you represent this in interval notation? It can just be -1, 1. So this is your domain. That's your domain. If you're having an issue understanding this, go back to the beginning of this video where we talked about interval notation. So in order to represent this in set builder form, you have to be x is an element, okay. X is a set of numbers such that x is an element of a real number, x is less than 1. Okay, yeah, there's something you need to understand here. You can actually combine these two inequalities together. You can have, since you have two inequality, x is greater than -1 and x is less than 1, you can flip this to be -1 is going to be less than x and x is less than 1. Just combine this, you merge the two x's together. -1 is less than x, which is less than 1. So you can, instead of writing this 2, you can just include it here, such that -1 is less than x, which is less than 1. So these are your domains, you understand? Now, I think this is the end of this. So the next video, we're going to talk about the applications of ranges in calculation.